If it's nonlinear, that means the graphs might meet more than once. You know, if you think about a parabola and a line, those things could hit twice. Do they have to hit twice? No, it would be possible for a parabola and a line to only hit in one point, or it'd be possible for a parabola and a line to never meet. So we can still get no solution, we can still get only one solution, but depending on the graphs we have, we might get more than one answer. And we could get more than two answers, depending on what we're looking at. You know, if I'm talking about a circle and a parabola, those things could meet in 3 different spots. So it will kind of depend on the functions themselves, how many answers we get. Our strategies, though, will be the same. We're going to rely on substitution and elimination. Yeah. Thank you. Okay, so I have an x squared, x, and a y. So, any ideas, any suggestions? If you had to, we could do substitution. What would you want to substitute in for? The y. Okay, that'll work. If we did that, let's say I took the second one and I solved for y. So that means y is 1 minus x. Sub that into the first one. So the first one is x squared plus y, which is 1 minus x, equals 7. This is a quadratic. We always set our quadratics equal to 0. So if I subtract over my 7, 1 minus 7 is negative 6. What multiplies to negative 6 and adds to negative 1? So if we set those equal to 0, we get x equals positive 3 and negative 2. So if I'm thinking about my answers, we have 2 different order pairs right now. We have to get the y for each of those order pairs. We know y is 1 minus x. So 1 minus 3 is negative 2. So put in the negative 2. 1 minus negative 2 is 3. And we can always check these. 3 squared is 9, plus negative 2 is 7. 3 plus negative 2 is 1. Negative 2 squared is 4, plus 3 is 7. Negative 2 plus 3 is 1. So they both work in both equations. So strategies are the same, substitution and elimination. We could have eliminated the y to begin with, and that would have worked also. The difference is you may not have just a linear equation to solve, so we may have to solve a quadratic. I'm not going to give you anything too crazy, so box method is about the most difficult strategy you'll have to use here to solve that. And then you might have more than one order pair. Let's put that in there. What would we do here? Elimination. It's already set up really to do elimination. If I add these, my y squareds will cancel already. So 1x squared plus 2x squared is 3x squared. 4 plus 8 is 12. X squared equals 4. Square root plus a minus so positive and negative 2. Alright, so now we have to find y. So if x equals 2, if I plug that back in to one of the equations, so I get 2 squared plus y squared equals 4. If I subtract over my 4, I get y squared equals 0. Square root of 0 is just 0. So 2, 0 is one of my answers.
What about the negative?
Well, let's plug in negative 2. So negative 2 squared plus y squared equals 4. So we get y squared equals 0 again, so y equals 0. So negative 2, 0. That's my second answer. It's possible that we might have solved that and got, if x was 2, we may have solved that and got y to be plus and minus 2. If that happens, that's 2 points right there. When x is 2 and y is 2, and then when x is 2 and y is negative 2. And that's going to happen sometimes. So if you plug in an answer and you get a plus or minus, that just gives you 2 different points. Questions so far? Here? No. So what should we do? Substitution. Okay, so we have to take one of the equations and solve for one of the variables. What do you want to do? Solve the bottom one?
Yeah.
For x?
Y.
Y? Alright. So we could subtract over the 5x. Divided by negative 3. So 3 divided by negative 3 is negative 1. Negative 5 divided by negative 3 is positive 5. Then we have to sub that into the first equation. So if we distribute, do you like having a fraction? So how could we get rid of it? So let's just take everything times 3. We get negative 3x plus 5x squared equals 36. This is a quadratic, so we would like to set it up so we can factor. So if we subtract the 36, we have to do the full box method this time. So we multiply to a negative 180, add to negative 3. Everybody can multiply.
Negative 15 and 12.
Mm-hmm. day yesterday.
They do it really well in the library too. And the library, yeah, the library is like shut off and you're like, come on, like shut off for like 2
I
seconds.
mean, there's not a storm. Oh, you know if it goes out, I'm just moving to the dry erase board. I've got this. I'm prepared. We'll open the blinds, it'll be enough light. It'll be
Yeah, let's
fine.
get the elementary and middle school are getting right now. 'Cause they have the power.
Alright, so I got 2 x's, so we need to find y. You can do that by plugging back into one of the originals, or we can use, we already said y was -1 plus 5/3 x. So what does that give us? -1 plus 5/3 times -12/5. So my first order pair is -12/5, and then -5. If I plug in my 3, -1 plus 5, so that's
Where were you plugging those into?
you could have done the originals. Remember at the beginning we used substitution, so we solved for y. So I just put them into that equation, but any of those options would work. And we've been getting 2 answers on all of these, but that doesn't mean you have to have 2 answers in everything. It could be more, it could be less.
Do you have more than 2 answers?
Let's do, I think I have 2 more, then I'm done. So I am doing a problem like every single one on the homework. So you will have an example very, very similar to everything we need to do. Okay. So this one, is elimination going to work well here? No, because we have x squared and y squared, so that's not really going to help me. Any other strategies that we could use? Substitution. Okay, so the first equation, if I were going to try to solve for one of my variables, we would have to add a square root and a plus and minus. So that's probably not going to be very friendly. So let's go with the second equation. Let's try to solve for one of my variables in there. It's a little bit different because we have that absolute value. If I took this, that means the absolute value of x is equal to a 4 minus y. Now the absolute value, what does that do? It makes something positive. If you think about the other equation, we're going to square. When you square, it becomes positive. So we really don't have to worry about the absolute value. It's just going to make it positive, but because we're plugging it into an equation where everything's squared, that takes care of it. So I'm just going to substitute this into the first one. So I'm going to replace this x with what my absolute value of x is, the 4 minus y. Okay, so if I have 4 minus y squared, that means you have it twice. So you have to FOIL. So we get 16 minus 4y and minus 4y, so minus 8y plus y squared plus y squared 2y squared minus 8y plus 16 equals 16. What happens now?
16's cancel.
Subtract over the 16 and that drops.
Take out the y.
So if you set those equal 0, you get y equals 0. 2y minus 8 equals 0. So then we just have to plug those in. Does it matter where we plug them in? No. So, I don't know, are you comfortable dealing with the absolute value, or would you feel better putting it in the quadratic so you don't have to think about the absolute value part? Does it matter? Okay. So if I plugged it in right here, the absolute value of x is 4 minus 0, so the absolute value of x equals 4. So what can x be if the absolute value of it is 4? It could be positive 4, or it could be negative 4, because isn't the absolute value of negative 4 4? So that gave me 2 points. 4, 0, and
Absolute value can be negative.
so what it's equal to can be negative. So the thing that comes out has to be positive, but what you put in originally could have been negative. On this one, we plug in a 4, and then we have the absolute value of x equals 4 minus 4, so the absolute value of x equals 0, so what's x? 0. So remember, in your ordered pair, you have to put x first, so that would be 0, 4. So this time we got 3 answers. Is that okay? Last. Would substitution or elimination be easier here? Elimination would probably work. If I wanted to eliminate the y squared, what would we have to do to the first one?
Negative 3 squared. Or, yes.
Just negative. So that would give me negative 3x squared. And that's 3y squared equals negative 15. Add negative 3x squared and positive 4x squared is just x squared. Those cancel. Negative 4. How do you get rid of a square? Square root, plus and minus. What is the square root of negative 4?
2y.
So now we have to plug each of those in to figure out the y. So if we plug in a 2i, squared. So 2 squared is 4 times negative 1, so it's just negative 4. Add over your 4. So we get y to be positive and negative 3. So we have 2 points here. When x is 2i, y could be positive 3. Or when x is 2i, y could be negative 3. What happens if you put in negative 2i? We still get the same thing, don't we?
Negative 2i times negative 2i is 4i squared.
Which is negative 4. So square root plus minus, we still get positive and negative. So we've got negative 2i, positive 3, and negative 2i.